It's on.
That's fine, as long as you've got a circle open.
It's on.
Thanks, man. So again, after you're done with the quiz, you're gonna fill out your table of contents for your water lab. Good students become great students when they have an organization system. And then you're gonna get out your changing chalk lab. Because we need to remeasure our rocks. Is this third hour or fourth hour? Thanks.
Quattro.
Thank you. Seth, can you give me, what was your starting mass? Or do you not have one? No, it should be the back page. Could you give me the starting mass that you all had, Keegan? What was the starting mass that you had before you put in that weak acid? 0.9. So I've got 0.9 here, and that was for Keegan's group. Can you raise your hand if you were in Keegan's group? Just Keegan.
What?
Okay. So then we've got 0.9 Keegan's group had before we dumped it in that weak acid. What we're going to do now is we're going to go back and we're going to mass out that little piece of rock one more time. And so then what did we see? We said that we were going to do day 1 observations and then we were going to do day 2 observations. And day 2 is like now. This is like kind of after, the second part of looking at it. Day 1, what did we notice on our rock? As soon as we poured that acid over it. Yeah, we saw bubbles being released. So we saw bubbles released. And the bubbles were being released from the rock. All right. Today when you get over there and all of your glasses are against the wall, it should have your class period and your table number on it. So what you're going to do with your group is you're going to have someone over there grab the glass that's got your table number for period 4. And you are going to notice that there's going to be crusty stuff on it. It's okay if you pick it up. It's just vinegar. Gently rinse off the rock and then pat it dry. And then what you're going to do is mass out that rock again. The rest of the materials at your tables, leave them alone. That's going to be for our water lab, and we're going to get that to that in just a minute. I will know that you're finished massing out when you and your group have cleaned out your glass, turned it upside down and put it over there with the other glasses that are upside down, and the tape is off of it and thrown away so that I know that we're ready to move on. My question that I want you to answer as a group at your lab table is this. How do we know that we chemically changed the rock? How do you know that you chemically changed the rock? That there was actual chemical weathering happening? Okay, so that's what you are going to talk about as a group. Then go ahead, rinse out the glass, throw away the tape, throw away all the crusty stuff, and then head back to your table and we'll talk about the water lab. I don't think it'll take us any more than 5 minutes to do this, so I'm going to put 5 minutes on the clock, and your time starts now. This is going to be the best class of the day.
I don't think you were.
Someone getting your glass? Someone getting your glass?
Over there.
All right. So this is what we've been waiting for. Where is it? Oh, right there. What are you noticing in it? That's not what we're doing, sweetie. Because you only are measuring the mass of the rock.
Oh,
Yep.
not bubbling anymore.
It's not bubbling anymore. But what do you notice about? Okay, so you notice that there's some sediment in there. maybe the acid is kind of cloudy. Where is it? Looks like there's some material floating around in there. All right, let's go ahead and take that rock out, gently rinse it off and put it on there and mass it out. Look at all the little
it's safe for
crusties.
hands, right?
Oh, it's safe, it's vinegar.
Oh yeah, it's vinegar.
Just vinegar. Notice that we have some crusties along the edge, some precipitate. Looks like the vinegar is a little bit cloudy. So write those things down. Wash that rock off. Mass it again, and let's see where we're at. It should only take you just a minute to write down your observations. Rinse that rock out. Mass it again. Clean out your beaker, please, and then flip it upside down.
What are you doing? When told you to do it?
Is your group done? Katie, your group done? Is your group done? When you're finished, could you please make sure that you are sitting down at your desks? And then we'll talk about our water lab. What? Throw it away. When you're done, it should not have gotten larger in mass. There is no way possible it got larger in mass. If you washed it off and patted it dry, there's no way. Sure, go quick. All right. Are we good? When you answer this question with your group, have a seat back down, please. No, definitely not. Did you? No, so don't use that scale. Use the scale that you used before, which is right behind you. Use the scale that we used before. You can't change technologies from one to the other. Just plug it in, man. You have 20 seconds to make your way down here. 20 seconds. Don't throw things. Michael, you're a high school student in a lab. Don't throw things in class. No, we're not kicking each other, Spencer and Michael. That's not what we're doing. Have a seat, please. Have a seat. I'm telling you, I'm stopping it. We don't act that way in a high school setting. How about this, Spencer? I don't want you to act that way anymore in a high school setting.
Alright. Well, I'm leaving the school anyway.
Yep. Please clean it out, rinse it out, throw away the tape, and then come sit down. Hopefully you had time to answer the question, how do we know that we chemically change the rock? So, Keegan, can you tell me what was this after it had been sitting?
0.5.
0.5. So we went from 0.9 to 0.5 in that one group. So can someone tell me, how do we know, what are some clues that tell us we actually did chemically change the rock? Yep. Yeah, has less mass. Rock has less mass. And because it has less mass, what does that mean happened? What did the rock lose? Mass, okay, yeah. But it changed itself, okay? It's chemically changed. What happened was we had two things. We had vinegar and we had the rock. They combined together. And did anybody see any crusty stuff? Did you see cloudy stuff in the water? Yeah, so that means we had new substances that were created. Rock has less mass and new substances were created. Originally, we saw gas bubbles, so we know gas was being created. Then, after day 2, we saw that the acid was cloudy. Okay, there was something floating around in it. We saw crusty stuff around the edge. No, Katie. We saw crusty stuff around the edge. Okay, so we saw that the rock has less mass, plus we saw new substances were being created. So we know a chemical reaction happened. What we're going to do now is we're going to transition from weathering, erosion, and deposition, and we're going to start looking at a substance called water that really does a lot in the weathering, erosion, and deposition realm. So we're going to dive deeper into water by doing a water lab. There are going to be 7 different stations at this lab. If you could please get out your water lab, I would greatly appreciate it. Now, my other classes are taking a little bit longer to get themselves acclimated to how to do this lab. So what I want to do is I want to give you some help and let you know that if you're typically somebody that dinks around in lab, this is probably not a lab for you to go ahead and do that, okay? We are asking you to step up into the lab. Now, I've seen some people that get a lot of practice in my labs because you all sit back and you let them run the lab. What we need to do is make sure that everybody's getting involved so that everybody understands what's happening. The lab is going to be broken up into 3 different ways. The first thing you're going to do at a station is read a small passage, have somebody read that out loud, and I want you to know that these readings are going to answer these questions above. So you might want to read these questions above, and as you are reading the passage, someone say, oh, hey, this answers question 1. Oh, hey, this one answers question 2. Okay, so that's what's going to go up there. After you're done with the reading, then you do the investigation. That's the second thing you're going to do. Then after you're done with the investigation, you've got some analysis questions at the end. Now I'm giving 8 minutes per station. That means that you have to dial in. That means that we're not wandering around to, yes, Kel, thank you for reminding him. That means we're not wandering around to other people's stations. We're not going to jeopardize other people's success, because then when you do that, you're also jeopardizing your own success. Okay, we need you to have this information. I am really saddened by having those conversations with people of, what can I do to raise my grade? You can pay attention to what we're doing now so you gain that information. So I'm going to get you into 7 different groups. You're going to be number 1, 2, 3, 4, 5, 6, 7. If you're somebody that's like, wait, what's my number? Please write your number down or put it on your fingers right now, okay? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. All right? So that means my number 1s are going to go to which table? Okay. So I need you to move to that table, and I need you to please note also the clean-out procedures. I'm going to put 8 minutes on the clock. Have somebody read the little reading first, out loud. We're reading out loud. Okay, you've got 8 minutes, and your time starts now. Pick someone to read out loud. Out loud, darlings. Michael, don't. Read out loud. Who's gonna read out loud? Come on, you're already a minute down.
Read it.
Well, all right. Well, let's read this aloud. Water, H2O, is considered a polar molecule. Polar molecules are those that have regions of positive and negative charge. A water molecule.
Is the greatest solvent on Earth. Solvent is a substance that dissolves or breaks apart another substance known as a solute. A general rule that determines whether a substance will dissolve. Right, I just want to try to get this on.
Is this the answer?
How do you say that word? What? Cohesion.
Is this the answer? When ice absorbs enough heat for the temperature to rise above 0 degrees Celsius, hydrogen bonds between molecules are disrupted or changed from arm's length to short, more easily breakable. The ability of ice to float due to its lower density is an important factor in the making of the environment suitable for life.
What? Adhesion? Adhesion and cohesion. Sorry, I just want to get this on. Shut the door because it's about to get crazy out there, all right? And here is this one on surface tension, which has a lot to do with cohesion. Now, it's very careful. What I would do is I would gently put it on there and then slide that onto the surface with your finger. I would do that, yeah. Put it in there, and then I would just, put it like, try to horizontal it, like in there. You got it. Just put it down in there so it's kind of touching the water, and then I'm just going to gently slide it. Oh, see if it'll stay. Just want to take a quick picture of this for my peeps at home. And we've got water and we've got alcohol. I just want to let you know, all of the stations that have a blue substance, I tinged all of the water blue. So if it's not tinged blue, then it's probably rubbing alcohol or something like that. Like this? Yeah. And you don't have to keep the pennies in there. You can put the pennies right on the...
We haven't started.
All right. And so, my people, that's what we are doing at home. We are working through each one of these stations. The reading I went ahead and showed you on each of them that answers the questions, and then down below, we are going to go ahead and do the investigations. I hope this helps. We'll see you tomorrow.